Hello, it's me, and I've been asked to have another go at this Witeden crazy 3x3 puzzle with the two circles on the top and the bottom. So I'm gonna try this again, try to clear up some of the unclarities of the first one, just to make things a little bit more easier to understand. It's not a very difficult solve in some ways, but there are a couple of sticky points that if it's not expressed exactly the way that it should be, it could be a little confusing. But I figured it was worth going through this again for a couple other reasons, because there's other puzzles that actually utilize the techniques that you can use for this puzzle as well. For instance, this I got from Witeden. It's pretty easy to get, pretty cheap. I do recommend getting this this puzzle. It's a nice one, very good variation. But you can also get this from Smaz. This is his version of it, found at the Smart Toy Shop. It's really the same kind of puzzle. The only difference is that you've got these small ends over here, but it's the same kind of thing. You have a circle over here, and the main difference is that when you turn it in this direction, you can also turn it back over here and use shapeshift. So if you like the shape-shifting aspect of it, then you'll enjoy this. But the aspects about this is we're kind of constrained, we're bandaged in many ways, because as long as you have all circles over here, you can move this edge pretty freely. But the second you take circles out of it, you can no longer move it over here or over here. You can move it from the centers that don't have the circles. So I can move here just fine, I can move here just fine, I can always do that. But I can only move this if I have all circles in. Once I do that, then I can move it. So there's a little bit of bandaging and constraining that happens. The same thing happens with this puzzle as well. If I turn it over here, all of these can move just fine as long as you don't have a circle center. But a circle center here becomes bandaged. Here it becomes bandaged not just because of the circle aspect, but also because of the shape of this. It almost has a 3x3x2 kind of a look to it as well. So you can solve those. But also the other puzzle that will use very similar techniques is this guy. You remember this? This is the Saturn crazy 3x3 plus puzzle, where you've got the top, which is bandaged, and the bottom with the center bandaged, but everything else is the same. Now, it's not solved exactly the same way. This is among the more difficult of the crazy puzzles. I've actually done a reboot of this one as well. You have to do the reduction, but after you've done the reduction, you pretty much reduced it to this puzzle over here. So after everything is in, then you follow the same rules and solve the rest of it, which is in the part 3 of my reboot version of this, exactly like this. So it's worth doing. Now, as I'm solving this, I'm actually going to do a tandem solve of both of these. The reason that I do it that way is oftentimes when I'm scrambling it and solving it, I may come about situations in one that I don't come about in another, so that I can make sure I'm addressing all the possible dilemmas and all the possible questions related to these puzzles. By doing two at the same time, I may be able to more broadly get more issues. So starting with a scramble here, we're just going to do 180-degree scrambles first. What I'm trying to do is really mess things up so that I've taken this out of its reduced form as much as possible. Just want to move this over here. And once again, just turning around. I'm just trying to make as many random turns as possible, and I'm trying to make it to where all of these are not in, so that I can kind of enhance the challenge of this. So turn, and that's pretty good. And I can do the same thing with this guy over here. Turn, just do 180-degree scrambles here. And it's the same kind of thing, because like I say, it's really the same puzzle. Now once you do that, in this case, you can start doing other moves where as soon as I do this, I can no longer turn these sides. So I'm really restricted to these moves over here, moving these sides like so. And every time I try to move this, it just doesn't work. With this one, it's going to be a matter of shape-shifting. So once again, I cannot move this side here, but I can move all the rest. And to any of you that might be considering buying this puzzle, this will be a good way to just kind of evaluate it, see how you like it. It's really the same kind of puzzle though. So I have to just bear in mind what I can and I can't do. Okay, I'm going to keep scrambling it. Abracadabra. Okay, we got it. Now, I'm going to take this kind of slow. So what you may want to do is you may want to push the pause a lot, go back, take notes, write down what you think is going on. I'm going to go through pretty much the same thing I went through last time, but I'm going to go through it a little more slowly and try to explain myself a little bit more with what's happening. And if you don't pick it up with this, maybe you can pick it up with this. So it's obvious that before we can do any heavy-duty solving with this, we're going to have to try to get these reduced. Once we get these reduced, we can start in with the solve. And we have to bear in mind the bandaging that happens with this puzzle. That even once I get all the circles up here, I'm kind of limited with some of the moves that, rather up here, I'm kind of limited with some of the moves that I can make. Now, because of the bandaging, just like with the latch cube, I have to variate some of the algorithms. So what we want to do, first off, before we even reduce the edges and the corners with the right color, before we put an inner and an outer yellow and an inner and an outer white together with these and with these, we have to make sure that these are coordinated with a proper center. The reason why is that if I don't coordinate it right, then there's going to be some steps at the last step actually that you're not going to be able to solve. And if you are able to solve it, you're going to have to figure out your own way of doing it, because honestly, I can't. So with this, I'll go through what we have to do and why we have to do it. But suffice to say, what you really want to do is you want to match up this outer part of the edge with the proper center. So what qualifies as being matched up with the proper center? Well, it would be pretty obvious to say that if this outer edge here was matched up with a red center, as it is here, this is matched up with a green center. Now you can say, well, couldn't you just, turn this around here, turn this over here? You can, but notice the way this is this can only go with this center or this center the way this is right now. So I can't turn this over here to bring this to here. This red, this outer red here, white and red, is trapped between the wrong center, either this one, the green one, or the blue one. So this basically is trapped between the green and the blue. Where I want it to be, is to be trapped between the red and the one just opposite red, which is yellow. This green needs to be either between the green center or the blue center, but not this. So this is an example of, those two are examples of edges that are, quote, out, because they don't have the variability. And again, it's going to become more apparent why I do it that way. Anyway, this one is also out. As a matter of fact, I think pretty much all these are out. I can't really find anyone that's actually in, except maybe this one. So this over here, this is actually in, because this orange is with the red. So you can see I can easily take it and put it to where it's got to be. So this is actually in because it's either by the orange one or the red one. So I hope that part is clear, because that's a key point. It's the same thing with this puzzle over here. With this one, this is a green one. If I move this down here, you can see it's out. This will never go to where it's supposed to be over here. This is also out over here. So here's step one to solving this. First step, before doing any actual definitive reduction, is get these edges by the center that they're supposed to be, which again is either the centers that they belong or the ones just opposite. And here's the technique of how you're going to do that. First off, we're not going to be doing any moving of any centers until we get all circles over here. And for this early part, it doesn't matter if they're all the same color. Just line them up so that we can start moving these into the proper centers. So what I'm going to do is I'm just going to start moving edges in here, bring this over here, bring this here. Okay. Now, these are in and that's fine. What I want to do is I want to move 2 in over here. So how am I going to do that? Well, what I can try to do is I can turn this here, but I can't turn from over here. So it's actually fairly intuitive, but the way that you're going to do it is put a corner just above or below, however you want to look at it, to where it's supposed to be. And let's hold the circle center in front of us, so this will be our front face and this will be our top face. That's going to be varying and changing. But suffice to say, on the top face is where I'm going to put the corner that belongs over here, in this case to the right side. And what I'm going to do to move this in here, I only have to institute this move here and this move over here. And that's going to be R-I-U, R-U-I. So if you do that, you'll get it in. The whole key is that the one that's in front of you has to be the circle side. So let's practice over here. Now, what this is going to work with is this is going to work with any corner that's in this layer. Any corner that's in this layer, if I do this enough time, it'll get this in here. And that includes the one that I just did over here, but also if it's over here or potentially over here.
So let's say I want to get this one in. If I keep doing that algorithm, this will eventually find its way over here. And this is on, so this is on the right side, RIU, RUI, so now it's here, RIU, RUI, so it's here, actually it's here now, RIU, RUI. So if I keep doing that, that's going to end up here. Same thing with this, red, blue, and this. And if I keep doing that, eventually it's going to work its way in. So it's a pretty simple commutator, and I'll bring that over here. So how about on the left side? Let's say I want to bring this into here. Now, it doesn't matter, this is where it's supposed to be, but it's in this plane. If I do a similar algorithm, but on the left side, I will be able to get this into here if I just do it enough. And on the left side, that algorithm, so it doesn't matter if it's here, here, it doesn't matter which direction it is, it'll eventually go in. Or this one will go in, it really doesn't matter. But just to demonstrate it, if this is the front face and this is the up face, this is the left. In this case, we do LUI, LIU, LUI, LIU. So that simple commutator will bring that in over there. The whole key is now I can move, now I've got the freedom to move this over here. Okay, so now because of that, I can start moving these guys in the proper center where they're supposed to be. Now in this case, you can see that none of them are in. Green is not in, red is not in, orange is not in, and this red is not in either. So if I just move this over here, this is in, this is in, this is in, and this is in. Now I'm saying they're in because they're within 180 degrees. So in that particular situation, if you have all of them out like I did, it's pretty easy just to put them into position. Now what I want to do is I want to start picking up the pieces, because in this particular case I had 4 that were out. Well, that was easy. I just turned it in. So that's one particular situation. But what if I just have 2 that's out, or just 3 that's out, something like that? Then I'm not going to be able to coordinate it like that, because I'll never have 4 or multiples of 4 that are out. So let's see how we can coordinate that. Once we have that, let's do another one. So here's this. Is this in or is this out? Well, this is obviously out. How do I know? Because when I put this in here, you can see that it's not lined up correctly. So this is where the strategy comes in, and this is where some people may be having difficulty. So once you have these in, let's move another one in. So I'm going to move this in over here. So this is here. I don't think I have equal numbers that are out. Is there anything else that's out? Well, this is in over here. This one is also out. So this one is out as well. And let's see, this one is in. I think we have a situation where just 2 are out. So we're going to have to do something with a little bit more strategy, and here's how we're going to do this. On the right side here, I'm going to put any one of these in. I can do it from the right side, I can do it from the left side, doesn't matter. I'll go ahead and do it from the left side as that's easy over here. L, UI, LI, U, so that's in. So how are we going to do this? Well, if I just move this in here, obviously these guys are going to be messed up. So here's the technique that I'm going to do. Take one that's out over on this side. If I turn this over here and then do a 2F, double turn this down, it'll secure that here and replace it with this. Then I can turn it back to bring these guys all back in. So imagine that in order to make this really work, I'm going to have another one that's out on the opposite side. So kind of visualize what's happening here. I'm taking this, moving it in. Now I'm going to double turn it to get it out of the way, but when I turn it back, this one, once it's in the proper place, is also going to turn back to here, which means this one is going to have to be lined up with the wrong center. So I hope that made sense. Just kind of pause it if that didn't. But what's going to happen is this is going to come into here, and I'm pretty much going to be replacing it with this piece. So this has to be out, and this piece has to be out. These two actually have to be out. This one can be in because when I move it, after I double turn it, I'm going to move it back. This one is going to be moved over to here. So basically what's supposed to happen is this piece is supposed to be here, and this piece is supposed to be here. And that's how I have to coordinate it. So when I see one that's out, look for the other one that's out. And that's gonna be, is it actually this guy here? Well, if I were to move this up here, you can see it's not, it's in. If I were to bring it where it's supposed to be, so it's not that one. So which one? Well, this one, nope, not this one over here. How about this guy? Well, if I put this on a circle side, it's gonna be in the wrong one. All right? So take a look at what I just said, make sure that that makes sense. But we are lining these outer edges up with the proper center. We have one here that's obviously not in. If this isn't very obvious, just match it up to the closest center that it can go to, and there's only one route that it's going to be able to go up to in the proper center, and you can see it's not in. All right, so that's how you see that, view that if it's upside down. But what I need to do is I need to move this over to here so that when I double turn it, it'll end up back over here. This also may take some positioning. But what I want to do is I want to take this piece and move it opposite this piece, because I want this to be one over from where this is. So this piece has to be opposite this piece over here. So this is going to be more, quote, intuitive, but if I turn this over here, and then I take this and turn it over here, now they're opposite, and then I bring it down. All right, so this is the confirmation that I want. So now I've moved this opposite. Now in doing that, I've taken this one and I've kind of batted it out of the way here. So this isn't the original piece. So by any means necessary, get this opposite. But now I have to take this one that was put out, and we've got to put it back in. So I'm just going to move this back into here. So if you're following what I did closely, you'll see that in the process of moving this out, I actually batted this down here. So I just move this over here. So now what I need to do is I need to put a corner in here. Now this is another part that gets a little complicated. Well, what if I try to move this corner in? I can either do it from the left side or I can do it from the right side. But any side I do it, I'm going to mess this up. Because if I do my algorithm, my little commutator, if I move this up here, turn, 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 I just batted this out. So I risk undoing what I just did. If I do it on the left side here, or right side rather, and I'm trying to move this up to here, I move it in. Notice I'm about to take this out. This comes up, down, and across. I just took this out. Okay, so stick with me on this one. We have to somehow move this into here without disrupting this, because remember, these two have to be opposite. One that's in and one that's out so that it can be replaced with this. So what I want to do is I do want to do that algorithm, but I got to do it in a way to where I'm not going to be affecting this side here. So what I'm going to do then is I'm going to take this association between this and this, and I'm just going to move it down to the other center that has the circle. That way it takes this out of the picture. So what I'm going to do is go 1, 2. So now I brought it down to this side, and I'm going to do the same algorithm with these two, but I'm no longer messing with this edge. I'm going to be messing with this edge. So we just do the same thing, L, U, I, L, I, U. Now that I have this here, I can now bring it back to the side that I was working on, which is here. So what that did is it did not take my association of these two away. This is still out, and it's going to end up here. This is going to end up here. Now in doing that, it's going to mess this side, but this is far from the action, so it really doesn't matter. What I can do at this point then is just move anyone back. So in this case, if I want to move this back in, I can move this up here. So let's get our bearings here. I want to put this one back in over here, and it doesn't really matter which one I use. Again, as long as these are opposite each other and this is here, so what I'm going to do is I'm just going to move this up and move this into here, like so. Then I got to remember to move this back. Now I'm not giving algorithms to everything that I'm doing because it's kind of a waste of breath. A lot of it you can just visualize what I'm doing. So now I'm going to make with the strategy that I talked about. So this is going to move into here now. So turn this to here. So now this is in. I'm going to double turn it. And now strategically this is positioned to come over to here. I have to make sure that I put corners in. Now at this point it doesn't matter what I do with this edge. It's already in. Once it's in, it can't be taken out. So I'm not going to worry about how to put these guys in. I'm going to hold it here and put this in. Same algorithm. So this is in, come over to here, and I'll move this here. I could do this, I could do this. It's the same algorithm on left side, rather right side or left side. Now that I've done that, I'm ready to go ahead and move it back. So orient myself back to here, and now everything will move back. Bang, this is in, this is in, this is in, and this is in. So all of these edges are now in. Now just in case you didn't catch that, we're going to do it again with this guy. So this puzzle is actually calibrated. Calibrated in that these are at the proper centers, and that's going to become useful later. So let's practice it on this guy, see if we can maybe hone some of those same skills with that. And if it wasn't quite as clear with this, then maybe with this over here. So to review again, so we have this will come over to here, turn it, and now we've got this one that's going to replace it and turn back the other way. So turn it back. And now it's a matter of, once we've done that, before we can turn it back, we've got to get the corners in. Could really be any one of them. So I'm just going to keep doing that little commutator until this, or for that matter, any one of them can come in. This comes over here, and just turn this. And once I have that in, keeping track of what we're doing, this comes across over here. So this is all calibrated here. So now all the centers are calibrated. Once we've done that, the next step, and that's the main priming that you have to do with this puzzle, now we're ready to go through the reductive process.